In this lecture, we're going to do another example on concept, and this is going to be a number concept. What this is going to do, it's going to make sure that we have a number. So we're going to declare the concept here using our template declaration. It's going to be a number. We're going to require that it is integral or floating point, but we're going to make sure that it's not the same thing as a bull or a car. And this is going to prevent us from having numbers that are implicitly convertible to bool or car. For example, if we have a function that is going to add up two numbers, we want to make sure that people don't pass in booleans or characters, and this is going to make our code much safer. So this is our simple function, which is going to be using our number concept here, and it is going to work really well. We can use that in our main function here. You see, we're going to static assert to see that a bool is not a number. We're going to see how this works out, but we can even use our function here to print out things, and we're going to see how this works out. Let's head over to Visual Studio Code and play with us a little more. Okay, here we are in our working folder. The current project is concept example 2. We're going to grab the template files here, and we're going to put them in place. And we're going to crack this open in Visual Studio Code pretty quick. This is going to give us our project here. We can remove whatever we don't need here. Let's clean up and clean up again. And we're going to include our concepts header because we're going to need that. And then we're going to do our simple function to add things up. We're going to make it a function template because we want it to add up two things, and we want this to work across a wide range of types. So we're going to say template type name here, and we're going to say T. We're going to be adding up two things, so type name T and U. And we're going to say auto. We're going to deduce the return type, and we're going to say add. We're going to say TA and the TB. We can do something like this, and we're going to return A plus B. We can do something like this. But the problem with this is that this is going to work. For example, if we say auto result and we say add, let's say 10 and 20, right? And say, I think we should use U as the second parameter here, and print out the result. We're going to say stdc out result. This is going to work. Let's pass this through one of our compilers here. We can use GCC. It is going to work well. We're going to have our template instance generated, and we're going to get our 30 printed out. If we run this, at least I hope, we're going to pass this through the compiler, and if we run, we're going to get a 30. But the problem is, this is even going to work if we pass in a character. For example, if we change this 10 here to a character, for example, let's make it C, for example, something like this. You're going to see that compilation is going to go through, and we obviously don't want something like this to work. What is the meaning of adding a character to a number? But this is going to work, and it is going to do implicit conversions behind the scenes. It's going to convert this C to its representing number, and we're going to add 20 to this, and we're going to get this junk here, which doesn't really mean anything. We want to prevent this kind of thing, and we can use concepts. So I am going to go on top here and set up my concept. It's going to be called number. It's going to require that our type is either an integral or a floating point number, but we're going to enforce that that type shouldn't be a bool or a character, because bool could also compromise our function template here. So this is what we can do. So we're going to require that the first parameter be a number, and the second parameter also needs to be a number. Now if we do this and do something like this, you see that we have a concept failure here. And if we pass this through the compiler, let's use GCC, I think it is going to do. We have a concept failure, so this shouldn't be the same thing as a character. This is failing. This is exactly what we want to see here. Even if we pass in a bool, for example, we pass in a true, and we try to pass this through the compiler, this is something we can achieve. We have a compilation failure, and this is failing because a bool is the same thing as a bool, and we don't really want that. Now our function is a little bit safer to use because the numbers that we pass in here should satisfy this concept here. And it should be either an integral type or a floating point type, and it shouldn't be the same thing as bool or car. And our concept is protecting us here in making sure that this function does exactly what it's supposed to do. For example, if we pass in 20.1, this is going to work because the first parameter here is a number according to our concept. And if we build, we're going to see that this is going to work. The build is good. And if we run, we're going to have something printed out that we really expect. That's going to be 40.1. This is really all I wanted you to see in this lecture, that we can do something like this. Another thing you can do is check your concept before you even pass that through any of the functions. For example, we can do a static assert to ask if a bool is a number. And you see we have a failure here, which is saying that a bool is not a number according to our concept. And we're going to have a concept failure here. But if we pass in int, for example, this is going to work. The assertion is going to succeed. And the bool is going to be good here. This is what you can do to play with concepts. This is all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.